Alright guys, today we're going to do application with the quadratics, so that means we're going to put this into real life application problems. So we're going to use the graph at the right. It shows the height in feet of a small rocket after it's launched for t seconds. This is the formula it gives us showing that the y-intercept is 0. So how long is the rocket in the air? So here is where it started. Bam, in 8 seconds. It lands. What is the greatest height the rocket reaches? That would be our vertex here. So we're going to look at our vertex. So that's almost, it's like 253, 252, 255, somewhere right there, feet. About how high is the rocket after 1 second? Bump, 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 right there. So I'm going to put 115. So as long as you're close to that, right in that area, you may put like 113. After 2 seconds, how high is the rocket? So we go to 2, and how high? 180 feet right here. Is it going up or down? It is going up at that point. After 6 seconds, how high is the rocket? Well, notice these are symmetric, so it should be the same. The only difference is now it is going down. Okay, do you think the rocket is traveling faster from 0 to 1 or 3 to 4? Okay, now from 0 to 1 would be our answer because you have speed here and you're slowing down to make that turn. Alright, so let's go here. T is represented in time. And it represents seconds. H is height or distance, and it represents feet. When an object hits the ground, its height is 0. Okay. After t seconds, a ball is tossed in the air from the ground, reaches a height of h feet given by this formula. Okay, what is the height of the ball after 3 seconds? So what is 3 seconds? It's our t. So we're going to substitute the t with a 3. Okay, so we get 432 minus 144. So we get 288 feet. So in 3 seconds, the ball is 288 feet off the ground. After how many seconds will the ball hit the ground? So again, h is 0 here. So we're going to factor, and I'm going to take out a 16t. 16 to go into 144 9 times, 16 to go into 16 1 time with a t left over. So I have 16t equals 0, 9 minus t equals 0. Divide by 16, t equals 0, subtract 9, negative t equals negative 9. Divide by negative 1, and I get t equals 9. So after 9 seconds, the ball is going to hit the ground because this is the initial spot. All right, let's keep looking. A rocket carrying fireworks is launched from a hill 80 feet above a lake. The rocket will fall into the lake after exploding at its maximum height. The rocket's height above the surface of the lake is given by this. Okay, so here we are. We are 80 feet above the lake, and the rocket is launched, and then it's going to hit the ground here. Okay, so how long does it take the rocket to reach its maximum height? That's going to be here at our vertex. Okay, we're going to have t for how long and h for how high. This is not in vertex form, so we're going to have to use the axis of symmetry formula, negative b over 2a. That gives me negative 64 over 2 times negative 16, which is negative 64 over negative 32. which is 2 seconds. So after 2 seconds, the rocket will be at its maximum height. What was the maximum height? So that's how high it was there. Okay, so we can take this 2 and plug it back in place of t to find our h. Alright, so that's going to give me negative 16 times 4 is negative 64, and 64 times 2 is 128, and then 80. Negative 64 plus that's 64 plus 80 is 144 feet. So the rocket's height above the here would be, the vertex would be 144. Okay, so let's look here. A rock is thrown from the top of a tall building. The distance in feet between the rock and the ground t after it hits is given by this. How long after the rock is thrown is it 370 feet? Okay, so 370 is a height, so it's going to go in place of d. If I asked you how tall this building was based on this formula, you should be able to tell me 382 feet because the rock is thrown at the top of the building here, and we know the top of the building is our y-intercept. So that would be at 0, 382. Okay, so first thing I have to do is get it equal to 0. Alright, so I have that, and then I'm going to factor to solve, or I could use the quadratic formula. So I'm going to take out a negative 4, since that is negative the first term, and I'm going to get 4t squared plus t minus 3. And then that's going to give me negative 4. And then I'm going to factor this by doing 4 times negative 3, because a times c. I'm going to get negative 12. 1 and 12, does that subtract and give me 1? No. 2 and 6? No. 3 and 4? Yes. The 3 has to be negative. So I'm going to have 4t minus 3 and 4t plus 4. So I got negative 4, 0, 4t minus 3. What's the GCF here? Is a 4, and that's going to leave me t plus 1. Squish that like a berry. Okay, have I solved yet? No. So I have to put this equal to 0. And the other factor equal to 0. Now, negative 4 doesn't equal 0, so I don't have to worry about that. Had that been a t, I would need to use it also. Okay, I'm going to add 3. I get 4t equals 3. Divide by 4. T equals 3/4. Subtract 1. T equals negative 1. I go back up and read my question because I need to know after all that work what I'm answering. How long, so how many seconds after the rock is thrown is it 370 feet above the ground? Okay, so how many seconds? After 3/4 seconds, it's 370 feet above the ground. Alright, so there we have that. So 3/4 seconds. What about this negative 1? We can't have negative time. Okay, so that means after 3/4 seconds, so here's 382, it's going to get higher and higher, so somewhere about right over here would be 3/4 and 370.